Hi, my name is Christopher Coates. This is my presentation for the IP414 um, project presentation. I will be doing my presentation on an outage that happened to Virgin Blue in 2010 as a result of a software service provider that they contracted with Navitaire. So here's a simple outline of how the presentation is going to go. I'll first give a brief overview of generally what happened. Then I'll get more specific and talk about the point of failure of the whole thing. Then the next section will be called What Really Happened, because the press release that they gave was a little vague, and we'll get more into it. And then we'll go over what an SAN is and how that has to do with the outage potentially. Then we'll go into lessons learned, and then what I would have done, and then where are they now, which is we'll see what has eventually come of the companies that were involved in this. So Virgin Blue is an Australian airline, and in 2010 they suffered a 21-hour reservation and check-in system outage that ended up costing them $15 to $20 million. It was a result of the outsourced Navitaire New Skies system that they were using, and there was an initial outage on September 26th that lasted 21 hours, and then there were even brief outages after that and delays that ended up accumulating to a total of 11 days where they were not in full swing and were taking losses. A lot of the cost came from compensating stranded passengers with hotel accommodations, credits for flights, and just the general lost revenue from missed opportunities for more sales. And that in total accumulated to the $15 to $20 million. So the point of failure was attributed to what Virgin Blue says was a solid-state disk server infrastructure failure. And as upon further review, something called a solid-state disk server doesn't really mean anything specific. And one of my sources that I looked into explored this and kind of noticed the vagueness of that statement. So if we look more closely at what this would have meant, it's likely that it meant one of two things. The first is that it was a simple SSD somewhere in the server, which shouldn't have been that big of an issue to where it would take 21 hours to restore. And as one of my sources quotes, it's a little odd that a mission critical application like this did not have at least one redundant drive in place. And so, though this might be what they mean, it is unlikely that something this simple for something this important would have been the true point of failure. But this leads us to one more sensible and likely explanation. So we still technically don't know for sure, but we can reasonably assume that the most likely reason and specific explanation for this failure was that it was a solid state drive that was a part of a storage area network. This much more easily explains such a long outage because an SAN is a specialized high-speed network that provides block-level network access to storage for the servers. And we'll look at a figure in the next slide that kind of gives an easy visual to see how this would play such an important key. And what would contribute to the really long re-up time is that storage area networks often use storage arrays, and um, you know, if in a storage array that one drive is dysfunctional, that usually means the whole system is messed up, um, or that drive misbehaving doesn't let the whole array work as it should, and um, yeah, is would be the culprit for not allowing access to all the data that is in that array. This is a pretty simple diagram of how a storage area network is incorporated into the general network structure between all the way from the clients to the servers and then to storage. And as you can see, right in between the servers and the storage is the storage area network. So if the storage area network is not functional, then the servers simply can't access the data that they need to. Um, and so, yeah, this is just a helpful visual to see that. And as said before, this is, I think, the safest thing that we can assume was the real um, culprit of this problem. So what are the lessons learned, or at least that I learned from this? Um, just generally, when you use cloud-based services, you are um, giving up control for convenience. Um, and with something that's so mission critical, that's a tough decision to make because that's something that you want to very much ensure stays up and functional. The second is to have a redundancy plan. If Virgin Blue had some sort of redundancy plan in place, even on top of what Navitaire had in place, even though this would, as it implies, be somewhat redundant, this could have saved, this is a simple thing that could have saved a lot of loss in time and therefore money. And third lesson I learned was not to consolidate these key potential places for threats into one place. And I'll explain that a little bit more when I explain what I would have done in the next slides. So what I would have done, especially after seeing what happened here with Virgin Blue and Navitaire, I would have, if possible, kept these mission critical functionalities in-house to ensure that I had full knowledge and control over it. And I guess the alternative to that is that doing due diligence when contracting a service provider to do it, if that was the route I were to take. But yeah, I would try to keep them in-house if possible. I also would have developed my own plans and procedures to handle external failures like this. In this situation, the process redundancy would have been the best form of failure prevention, or at least diminishing the huge impact that this had on Virgin Blue. And lastly, I would have isolated this consolidated point of influence by contracting two separate companies and services. So what I mean by that is that Navitaire both was the developer of the software and offered their software as a service, but then in turn they host their software on either their own infrastructure, or they even purchase the service outsourced from them to yeah to use their infrastructure. And so that's two major things, both software and infrastructure, that are out of Virgin Blue's control. And to me, all that relies on Navitaire, and that's a lot of responsibility and influence for, someone that's not you. And so, to me, I wouldn't have done that. I would have, if possible, separated these two services where I would purchase and use Navitare's software and then have a separate company host their software. And maybe that would take extra work to get the two to play nice with each other. But, you know, those are more worth these drastic, costly public outages. So I've given a descriptive analysis of what happened, why it happened, what I would have done differently. And so this slide is just devoted to seeing, okay, what happened farther in the future. What was end, the end of these companies and everything. So in 2011, things finally settled between Virgin Blue and Navitaire, and through the whole situation, luckily, they didn't have to go through court, and there was no lawsuits or anything. But shortly after that, in 2012, Navitaire crashed again, and it seemed that Virgin Blue believed in second chances, but definitely not third ones. And so they took the hint and switched their systems completely onto a new service provider called Sabre. And through this whole process, too, possibly because of this public outage, they changed their name to Virgin Australia instead of Virgin Blue. And so Virgin Australia is still around today. I believe Navitaire is as well, but certainly not as big as maybe they used to be. But so this is what happened to both of these associated companies. So that concludes my presentation. I hope you enjoyed it and that it was maybe a new topic that you haven't heard before and gave you even further insight into the realm of infrastructure systems in data related outages. Yeah, so just wanted to say thank you for how well you've conducted the class this semester, and I've definitely learned a lot and feel better equipped to pursue my hopeful career as a database administrator one day. Thank you.